And I'm going off script for some of these notes because we already know some stuff. So, by the way, my favorite alternate name for the intercepts is I call it the Jameis Winston lesson.
Oh.
He likes to throw interceptions. It's a football joke. Anyway.
I knew it was something like that. I was thinking 30-30 because 30 picks and 30 picks.
Yeah, so we already kind of discovered this with my StockX gift card, right? To find the x-intercept, so where it crosses my x-axis, what value do I know, no matter where it's at?
0.
What's 0?
Y.
It's when y equals 0, no matter what. You can pick anywhere on that whole x-axis forever. And y always equals 0. Like, I don't even have to know the equation. I know if it crosses that, y is 0, because it's not up or down at all. Now, what about on the y-intercept? Yeah. When x equals 0. No matter what, forever. Like, it has to, because it's not left or right at all. So I'm going to use that to inform how I find my intercepts from an equation. Well, guess what, guys? This one is already in slope-intercept form, right? So we already have an intercept. Which intercept is that intercept?
The y-intercept.
That's the y-intercept. And I'm going to write my y-intercept as 0, 6. I like writing my intercepts as ordered pairs because that gives me the location on a graph. Okay. Now, I explained it to you the other day how I know that's the y-intercept. It's because when the y-intercept happens when x is 0. And when x is 0, what happens to all of 3x? It's gone. It's gone, right? So when x is 0, y equals 6. Well, that's what my ordered pair says. When x is 0, y is 6. Now, I also need to get my x-intercept. The x-intercept happens when y is 0. So when y is 0, 0 equals 3x plus 6. You guys follow? All I did is I know where it crosses the x-axis, y has to be 0. So I'm putting 0 in for y. That's what that means. And so really what my equation is saying is when it crosses the x-axis, 3x plus 6 has to equal y value of 0. Well, I know this thing called algebra, because we're in algebra. I can solve for x and get a value of negative 2, which tells me my x-intercept is negative 2, 0. Big picture, the x-intercept happens when y is 0, the y-intercept happens when x is 0.
Wait, so all you did was
That's smart.
0 equals. So you just replaced the y with a 0?
Yeah, because on the x-intercept, what does y equal?
0.
0. So I put so what I'm saying then is when y is 0, x has to be this, which is where it is. But you're thinking task. I'm thinking big picture. I'm thinking where it crosses my x-axis, y has to be 0. If y is 0, then 3x plus 6 has to equal 0. Okay. So I take that wider approach. Okay. An analogy I used first hour that I like to think of is when we think of individual tasks, we're kind of like looking at little pieces of stone or glass in a mosaic. You guys know what a mosaic is? Okay? So the individual tasks we can be like, man, I understand this little stone, and I understand this little stone, and I understand this little stone. If you're just looking at little stones, you have no idea what the picture is. But if you like take a step back and think about how all those little stones are interacting together, you see a mosaic, and it's something totally different, right? Sounds like I should be teaching yoga right now, maybe.
Yeah.
But it makes sense. If we take a step back, think big picture, think about how things are connected, it's way better than looking at little individual skills because we forget and mess up individual skills, okay? So, let's practice. I'll practice on I'll do number 2. You guys will do 1 and 3 kind of and then check in. So number 2, I'm going to pluck that y-intercept because it's just there for the taking, right? You guys see that? We already know in slope-intercept form the y-intercept's at negative 8. Right? When x is 0, y is negative 8 is the reason that works. Okay? So next I'm going to work on the x-intercept. And what do I know about the x-intercept, Drew? It's when y equals 0, exactly. So when y is 0, 1/2 x minus 8 equals 0. To get x alone, I'm going to add 8. You guys know what the number 1 most wrong answer I get here is? It might be the answer you think it is right now, which is kind of...
Negative.
4 is the number one wrong answer I
Maybe
get.
16.
It's 16, yeah. You get rid of 1/2 by multiplying by 2. So x is 16 for 16, 0. We get rid of half and half x by multiplying by the reciprocal 2, right? So the reason I kind of saw that coming is I've been seeing those mistakes happening still. Fraction work. I think it's because of the Rona. Those months off got us. All right, I want you to try number 1 and 3 kind of on your own, and then we'll check in. So I'm going to go ahead on number 1. I'm going to take that y-intercept because it's just right there for the taking, right? 0, 5. For my x-intercept, I know it crosses the x when what, James? What is always true wherever it crosses the x? Along my x-axis, what value do I always know, James? How far up or down is it? If it's on the x-axis? 0. So which value is 0 on the x-axis? Well, x could be like 1, 2, 3, 4. X could be a lot of things. If I'm not up or down, what value is 0? Which one tells me up or down, x or y? Y. So y would have to be 0 because I'm not up or down at all, right? So the x-intercept where it crosses my x-axis is when y is 0. And when y is 0, 0 equals negative x plus 5.
Is it okay if we plug in a negative 1x just to make it easier?
Sure.
That's what I would.
So negative 5 is negative x.
Yeah.
So x is 5 on the intercept. 5, 0.
I thought that was wrong. 'Cause
All
I
right.
didn't see it.
Okay. Number 3. I'm going to take the y-intercept. It's there for the taking. 0, 2, right? When x is 0, y is 2. And Amelia, what do I know is true about the x-intercept? Y equals 0. So when y is 0, 0 equals negative 4/3 x plus 2. I'm going to subtract 2. So negative 4/3 x is negative 2. I'm going to multiply both sides by negative 3/4. Cross simplify, and I get positive 3/2. So I'm going to write 1.5, 0. I think 1.5 is just easier in my head to put a spot on a graph, or 1.5, than 3/2.
Yeah, that's what I was
So unless your graph had a scale by halves, then 3/2 would be kind of nice. But cool. How I feel? Big idea though, right? Big idea is
so easy.
it crosses the y when x is 0, crosses the x when y is 0. Here's what's cool about this. How many points is this always giving us? 2. So watch how easy this is to do now.
You can
5
just-
minus
yeah.
0 over 0 minus 5 to get slope.
Yeah.
y2 minus y1 action, and there's always a 0 in there. That's kind of nice. Also, what can we do with 2 points with a line?
You can create a line.
You can graph a line with 2 points. Okay? And watch, it's about to get even cooler and even easier. That's not usually what you hear as a math lesson goes on. Anyway, so check this out. What do you notice about these equations compared to the last ones? What form we in now? Standard form. And here's what I love about standard form. And my 8th grade teacher, Mrs. Warner, I really liked her, but she never let us mess with standard form. She's like, just get in slope-intercept form. Every time standard form, we solve for y. Every time. And that's actually kind of whack. But she thought she was doing the right thing. She's a really nice lady. But here's the deal.
She was not a good teacher, though?
No, she was. It was different times, man. Do what the teacher did. Don't think for yourself. Different times.
Was
But
it the Great Recession?
x minus y equals 2. Now here's the deal. This is standard form. I would not get into slope-intercept form, even though I can pretty easy, because Miss Warner made me practice that a lot, obviously. But what do I know about the x-intercept? No, it's when y equals 0. So check this out. When y is 0, what happens to this whole minus y junk?
Nothing.
It's gone. So when y is 0, x is 2. So the x-intercept's 2, 0.
Now you know the
Okay?
y-intercepts too.
Now, the y-intercept happens, Emma, when x equals what? 0. So when x is 0, negative y equals 2. Y would be negative 2. So actually, kind of, standard form is really nice for finding.
It's much easier.
Yeah, not all the time. So ax plus by equals c. If c is divisible by a and b, Really nice to get whole numbers. It's still actually pretty easy. You just don't always get whole numbers. But I'm giving you nice examples on purpose here so you can see the value. Now, let's look at number 5 then. Also, think back to the StockX example in our intro, right? We found intercepts using intuition. So the x-intercept happens when, everybody say it, y is 0. So when y is 0, 3x equals 12, right? You guys seeing that? I don't need to plug it in for y because 2, whatever it is times y is 0. So I divide by 3. The x-intercept has to be 4, which is 0.40. All right. The y-intercept happens when? X is 0, which means negative 2y has to equal 12. So y would have to be negative 6. And guys, with me, I just look at it and I can pull them because I just divide my c value by a and my c value by b. I'm talking about the ax, by, c thing. So I can just see it and know it, which means graphing these, but I can graph them by looking at them because I just plot the, you'll see what I mean in a minute. Okay. One more here. So the x-intercept happens when y is 0, and then sometimes I remember like doing this, and the y-intercept happens when x is 0. I'd set them both up kind of like this, and then solve. So I got negative 5/4, 0, and I've got 0, negative 1. But again, with practice, you're going to be doing that division quick and in your head, okay? So like standard form's kind of the bomb for finding intercepts, right?
This is unit 7.
Unit 7, yep. Standard forms are the bomb for finding intercepts.
This is like the easiest we've done so far.
Well, no, it's you need all the other stuff to.
How's this
There's
more
actually-
easy than the
Can we
last?
write it as negative 1.5 instead of negative 5?
You could write it as negative 1.25.
This is definitely not the easiest thing.
Okay, so here's where it really gets awesome.
Awesome.
Check out. Let's do number 8 first.
Pure awesome.
Yesterday, to graph number 8, you had to do this. Not even yesterday. This morning, you added 4x to both sides. And this took you longer than it's about to take me, right? You divide both sides by 5, and you got 4/5 x plus 4. You graphed the y-intercept of 4. You went 4 up, 5 right. Correct?
Yes.
Check out how I'm going to graph this. The x-intercept is negative 5. The y-intercept is 4. 1, 2, 3, 4, 5. 1, 2, 3, 4.
How do you, just because it's the coefficient of x?
Because it's standard form. So how I pull those numbers off quick is I know negative 4x has to equal 20. Because when y is 0, this is true. When x is 0, 5y has to equal 20. And I do that division in my head. I just see it, from practice. You guys would probably want to do your divide.
Oh, yeah.
And then you
That
get your
makes sense.
x and y intercepts. You only need 2 points to graph. Now, here's what I want to show you that's actually really cool too. Check this y-intercept I got 4. Still the y-intercept of 4. Check the slope of 4/5.
So easy.
Up 4 right 5. It's still there. It's the same exact line. I'm just using different skills to get different things I would need to make my line. But the slope-intercept form still works, right? Which one of those is quicker for me though? Graphing with the slope-intercept form or finding the intercepts?
Finding the intercepts.
Different tool in the tool belt, okay?
Why
Yeah.
don't we do
Teach us finding the intercepts first.
Because we were messing with slope-intercept equations first.
So why do we have to know slope intercept?
Well, if I taught you both these things at the same time, well, slope-intercept makes sense. So here's, I'm going to pause the video for a second. All right, so I want you guys to practice number 7, graphing using the intercepts, okay? So when y is 0, x is 3. When y is 0,
Wait, it's negative.
when x is 0, y is 3. When x is 0, y is 3. So 3 on my x for my intercept there, 3 on my y for my intercept there. I got myself a line. Now, don't do this, but if you wanted to get this one in slope-intercept form, y would equal negative x plus 3. Check it out. Y-intercept of 3, down 1, right 1, down 1, right 1. Still works. Same line. Just a different way of looking at it, okay?
Oh, yeah.
All right. I'm going to roll through 9 and 10 with you just to save time and then get you working on the homework, all right? Sound good? Some of you probably started it, didn't you? So,
It's not.
I know, on purpose, because I want you listening.
I know, I was actually going to
All right, so for 9, when y is 0, 9x equals 45, which gives me an x-intercept of 5. That's 0.50. 1, 2, 3, 4, 5. Okay? When x is 0, negative 15y equals 45. And guys, I encourage you to be like showing work like this. I'm going to let you know I don't because I can just like see it now. And then it gets really fast. But when I was in your situation, I wrote this all out.
I never show them. I think it's a message.
Alright. Now, don't do this, but I'm just going to prove to you that it's still the same equation again. Maybe this is the last one I'll prove to you. Subtract 9x, negative 15y is negative 9x plus 45. Divide everything by negative 15. So y would be 3/5 x minus 3. Check it out. Y-intercept of negative 3. Oops, don't do that. Up 3, right 5. Same line. Different way to do it. Now, another point I want to make is doing this would take you a while, right?
Yeah.
Doing this,
No, definitely.
way faster for you, okay?
I like that.
All right, let's look at this last one. All right, so when y is 0, 2x equals 7, which gets me an x value of 3.5. 1, 2, 3.5. When x is 0, negative y equals 7, which means y equals negative 7. 1, 2, 3, 4, 5, 6, 7, 8. That sounds pretty 5 years ago now, isn't it? The 21 Savage song. Okay, there it is, guys. Now, before I send you loose on your homework, who can tell me big ideas from today? Because the big ideas, I use the big ideas to inform what to do. Joe, give me a big idea.
A big idea. Wait. Okay. Wait. It's x. You can find the x-intercept when y equals 0, and the y-intercept when x equals 0.
Third big idea I want you to have, which you probably know it, but you don't know a big idea. Standard form is the bomb for intercepts, okay?
Is that on video?
Did you notice standard form was easier to mess with those intercepts than slope intercept? Slope intercept wasn't hard, but we had to like do 2-step equations versus a 1-step equation. But so I like to point that out because people in my generation or your parents, they're probably used to only messing with slope intercept to do stuff. And you're missing out if you're not getting those intercepts from a standard form equation sometimes, right? Like, if I get a standard form equation that says graph this thing, my first inclination is to try to do intercepts. When I was in school, my teacher would be like, nope, you have to put it in slope-intercept form. And I'd be like, listen, I got a y-intercept of 75. Why don't you just let me, I don't know. I could just look at you. Anyway, I didn't know. You don't know what you don't know. So, let me open that homework up for you.